Section 8.5, solving radical inequalities. Just got done with radical equations. Very similar, but has a little extra to it. I'm going to skip straight past this box and just show you what it's saying. So basically we're talking about, we need a quick reminder here of how we did number line graphs or number line shading for compound inequalities. And a compound inequality means it has more than one. So if you notice in each of these boxes, there is more than one, and it has the word and, which implies more than one, right? So and. So you may recall in the past there's such a thing as an or problem, but for the radical inequalities, all we're going to be concerned with is the and. So quick reminder on how this works. If you have an x less than 9 in this first box, we made an open circle, and less than means we would have shaded to the left. The x is greater than 5, also an open circle. Greater than, we would have shaded to the right. So the goal is simply to see where the shades overlap. Well, pretty obvious that they overlap from 5 up to 9. So in all honesty, the shading is actually kind of optional. The solution set is what's important. So if you would have known that implied, the original problem implied the answers were between 5 and 9, you could get away with skipping the number line, but I don't recommend that. So we're going to go interval notation. Without the equal to and an open circle means that we use parentheses. Remember, brackets were for closed-in circles. My shade starts at 5 and goes up to 9. And the 9 also has an open circle, so it gets a parenthesis as well. So the second graph, I was being a little bit lazy. It's important that you do realize, though, that negative 11 is definitely smaller than negative 1. So I'm going to start with the negative 1. And it does say b is greater than or equal to, so closed circle, greater than, shade to the right. The other one does not have the equal sign, so open circle, but it does say greater than, shade to the right. And where do these guys overlap? Well, they overlap up here. Now, as far as the circle goes, if the shade had gone all the way down to the negative 11, I would be using an open circle because it's associated with the negative 11. But since we literally started our graph by making a closed circle for that negative 1, well, that's just going to transfer right down there. So as far as the solution set goes, this time I'm going with a bracket because it's a closed-in circle or has the equal sign with it. And the shade goes from negative 1 to the right forever. Remember, parentheses always are associated with the infinity sign. So there's a solution set for that one. The last one. We need to put some numbers on my number line, obviously, 0 and 6. So let's start off with the y is greater than or equal to, or less than or equal to 0, which means closed circle, shade to the right. The other one also has the equal to, so closed circle, but it's greater than, so shade to the left. Well, the goal, guys, is to see where the shades overlap. I'm not seeing anywhere. From 0 on down, I got the top line. From 6 on up, I got the bottom line. In the middle, I've got nothing. So nowhere in that graph do they overlap. So no solution, always a possibility for this. All right, let's drop down here and see how that works with the actual problems that you have to do. So let me zoom in here a little bit. This is going to take up some room. All right, so notice the box. It gives you some drawn out steps that you have to do. Step number 1 is set what's inside the square root greater than or equal to 0. Let me do that and solve it, and then I'll tell you why we're doing that. So inside the square root, it says x is greater than or equal to 6, and that's supposed to be set greater than or equal to 0. Now I'm going to write the word and because we have to do something else here in a minute. So let me solve that. Pretty obvious, you subtract 6. I got x is greater than or equal to negative 6. Now here's why. What if you use a number that's not bigger than negative 6? Negative 7, for instance. If you were to plug a negative 7 into that problem, it would say negative 7 plus 6, which is negative 1. What's the square root of negative 1? Well, square root of negatives are imaginary numbers, and imaginary numbers are not on the number line. So that's impossible. So we can't use those values for our problem in the first place. So that's why we have to have this little extra piece to do. So the other part, so that was step 1. Step 2 is to solve the original problem. If you understood the last section or last part of this, which was just to solve equations, you just basically solve it like an equation. So how do I get the 1 to the other side? Subtract it. How do we get rid of a square root? We square it. And last but not least, how do I get the 6 to the other side? I subtract it. Oops, I never did square the 3. So this guy should have been a 9. And that guy ends up being a positive 3. Sorry about that. All right, so there's our two answers. And now we're going to do step 3 in the box, which is to use a number line to figure out the solution set. Now, again, number line is really optional, to be honest with you. But I highly recommend it. So here's the negative 6. Here's the positive 3. So the negative 6 had a greater than or equal to closed circle shaded to the right. The other answer had less than or equal to closed circle shaded to the left. Where do these guys overlap? Well, they overlap in between. So transfer that closed circle, transfer that closed circle. So we're going to use brackets for our solution set. And it goes from negative 6 to positive 3. The 3 also has a closed circle and therefore a bracket. All right. Next problem, same deal. I want to take what's inside the root, make it greater than or equal to 0, and solve it. Adding the 6, dividing by 3. So there's one of my two answers. So and, I'm just using an and symbol. I'm not going to rewrite that problem in the interest of time. I would hope you'd know, looking up there, there's a plus 4 I need to get rid of first. So I'm going to go ahead and subtract 4 first. Again, how do we get rid of a square root? We square it. See if I can remember to actually square the 3 this time. Got it. Going to add 6 to both sides. Got it. Going to divide both sides by 3. Got it. Okay. And I'm going to use a number line to help me out here. So I've got a 2. I've got a 5. This guy was greater than or equal to, so I want to go close circle and shade to the right. The other one, let's go different color, also had a closed circle, but that one's shade to the right as well. And where do they overlap? Well, they overlap from here on up. So just like one of those problems up above that we did, I'm going bracket because it's an equal to. Shade starts at 5, goes on forever to the right. And that's that guy. Okay, let me reduce this back down so we can actually find that third problem. Let's do that guy really quick. So number 3, and yeah, there's 2 problems to solve, but I highly recommend that you do this first. What's inside the square root has to be bigger than or equal to 0. Solve it. Don't let the number 0 scare you. I'm just going to divide by 5, and I get 0. So yeah, that's possible for an answer. And solve the original problem just like you normally would. Well, I threw this one in here just to see if you're paying attention. So how do we get rid of the negative 6? That's a divide. I'm left with the square root of 5x greater than. Oh, wait, what happens if you divide by a negative? That's right, you got to change that guy into a less than. Alrighty, square both sides. Divide by 5. I get x is less than 20. Number line, 0, 20. First answer, shade to the right. Second answer, open circle, less than, shade to the left. Where do they overlap? Now again, the 0 originally had a closed circle, so that's why I'm going with that. The 20 originally had an open circle. So bracket for the 0 because it's closed in circle. Where does the shade end? It ends at 20. 20 does not have a closed in circle, so I go with parenthesis. All right, 4 and 5, especially 5 is a doozy. So I would highly suggest you check out part 2 video and see how to solve those two. And number 4 is a little quirky as well. Thanks for watching.